All right, today we are going to talk a little bit about mechanical energy. We've actually talked about this word, we defined it when we talked about forms of energy, and we defined it as the energy of motion and position. Then we talked about it when we did our notes over kinetic energy, because we said kinetic energy is a form of mechanical energy, and the same with potential. Potential is a form of mechanical energy. So when we're looking at our definition, we say it's the energy of motion. Well, we know from previous classes that the energy of motion, that's just kinetic energy. And when we say the energy of position, that's our stored energy, and that is potential energy. So mechanical energy is the combination of these two. It is the sum or total amount of kinetic and potential energy, because we take into account both the motion energy that an object has and possibly any stored energy that it still has, or potential energy that it still has. So our equation for mechanical energy is mechanical energy, ME, equals potential energy plus kinetic energy. We just add the two together. So I'm going to go through and label these to make sure we've all got what each of these variables is. So this is mechanical energy, and just like all other forms of energy, it's measured in joules. Here we have potential energy. We know that's measured in joules as well. And our kinetic energy, also measured in joules. All right, so when we're thinking about our roller coaster is exactly this combination. We're using gravity to move our marble through our roller coaster. So that means it has to have stored energy to convert to this energy of motion so that it actually moves and makes it all the way through the roller coaster. So I'm going to draw myself an example roller coaster over here. Your all's designs all look way better than this one, but this is what'll help us get through the notes. So I have a really simple roller coaster here, and this would be my marble. We'll say that my roller coaster is, just make it easy, 10 meters high. And let's say the mass of my marble is 5 kilograms. It is a huge marble. All right. So let's start with this position, because one of the things I'll be doing today is having you guys calculate the amount of mechanical energy your roller coaster or your marble will have on your roller coaster. And that includes finding the potential and kinetic energy at different points along your roller coaster. So my points, I'm going to do, let's do 3 points. Remember, you can pause this video at any time, follow along, rewatch it, whatever you need. So let's start with our initial point. So we'll call this number 1. So for point number 1, this is our initial position. If I wanted to find the potential energy here, I would use my potential energy equation, which is mass times gravity times height. And I'll just come right back over here to my drawing to find those things. My mass is 5 kilograms. Gravity is 9.8 meters per second squared. And I'm going to start at a height of 10 meters. When I plug all of that in on the calculator, my potential energy is going to be equal to 490 joules. Now let's find the kinetic energy for this point. We already said that our marble is going to only be influenced by gravity. So when we first set the marble up here on the roller coaster, we don't want to give it a push. That would be transferring some of our energy to the marble. So instead, what we're going to do is we're just going to set the marble there and let gravity take over. So we are going to start from rest. And that's important for our kinetic energy equation, which is 1/2 mass times velocity squared. So I've got 1/2 mass I'm going to get from my equation, which is 5 kilograms. And then we start from rest. From rest means we're not yet moving, so that's 0 meters per second. And that would be squared in our equation, but it doesn't really matter here because 0 times anything is going to give us 0 joules of energy. All right, so now if we wanted to find the mechanical energy at this point, so all of the object's energy together, mechanical energy equals potential energy plus kinetic energy. So I'm going to take the values that I have up here, which is 490 joules and 0 joules for kinetic. So my total mechanical energy is 490 joules. All right, what's important about this highest point? We know energy cannot be created or destroyed. So that means our energy cannot be created or destroyed. That means however much energy I start with, I'm going to retain that amount of energy the entire roller coaster ride. That energy will convert between potential and kinetic as we go, but the total amount, that total mechanical energy, is going to continue to add up to 490 joules because I can't lose any of that energy and I'm not going to gain any additional energy because we won't be touching or adding springs or anything to our roller coaster. So let's see what that means in terms of our equation. So let's say this is point 2 here, and point 2, our height is, we'll say this part goes all the way down to the ground. So our height here is 0 meters. So let's see what happens when our height decreases. So I'm going to do point 2 over here. And again, I know height. I know the mass. So let's start with potential energy. That's what you'll want to start with each time. So potential energy, again, mass, gravity, height. In this case, I'll do this below. Mass is still going to be 5. Gravity is still going to be 9.8. But my height now is 0. And what is anything times 0? 0 joules of potential energy. That's okay though. We can go down to 0. It's just because your marble doesn't have any farther that gravity can pull it down. Gravity has already pulled your marble down to the lowest point possible. So where did all of that potential energy go? Well, it's going to be converted to kinetic energy. But the trick here is we don't know the velocity right away. But I can figure out from my mechanical energy equation how much kinetic energy I would have there. So here we're going to rearrange. We're going to start with potential and then calculate our mechanical energy, which our equation is potential energy plus kinetic energy. So So how do we plug in our values here? I'm going to bring down equation symbols, but we just calculated potential, which is 0. And mechanical, remember, we can't create or destroy. So I said this is the maximum amount of mechanical energy I can have because it's at my highest point, right up here. So that means that's my mechanical energy the whole time. So we'll plug it in there as well. I don't know my kinetic energy. That's what we're looking for. So now I've got an equation. I have one unknown. I can solve this. Lucky for us, 0 has no effect. So we could cross that out. And what we're left with is 490 joules of kinetic energy. So at the lowest point on your roller coaster, what you'll see is that all of this initial potential energy has converted into kinetic energy. If we're at kinetic energy, do you think our roller coaster is going to be going much faster or much slower? Hopefully you're thinking, oh, it's going to be going faster because now all of that stored energy is motion energy. So we know this is our new kinetic energy. Well, what if we need to know how fast it is? And you do need to know how fast it is today as part of your preliminary calculations. We know how to solve our kinetic energy equation for velocity. Velocities are unknown. So I'll make a note here. We're looking for V. We don't know what V is. So we're going to plug in our kinetic energy, it's 490 joules, plus 1/2. My mass from above is still 5 kilograms. And V, that's the one I don't know that I'm looking for, so we leave it as a variable. I'm going to start by simplifying these two. 490 joules, 1/2 times 5 gives me 2.5. And then I've still got my velocity squared there. Now I'm going to divide both sides by 2.5, so it cancels over here on the right. I'm writing a little small so I don't run out of paper. So 490 divided by 490 divided by 2.5 is going to give me 196. 196 over here. And that is equal to V squared. So the last step is to undo the square. So to cancel that square out, I'm going to square root both sides. So V equals the square root of 196. Oh, that's nice. It's a nice whole number. 14, and our units are always meters per second for velocity. So at point 2 here, I now know that the height was 0, and that, let's do the velocity is 14 meters. 14, try that again, meters per second. All right, what about point 3 here? It's about halfway between 1 and 2, so we'll say the height here at point 3 is 5 meters. So we're going to come down here. I'll draw some lines so that we can keep our work separated. So this is going to be point number 3. And again, we're going to start with potential energy. because I have the most information about position, because I know how high it is and I know the mass. So for our potential energy, mass, gravity, height is our equation. Mass is still 5 kilograms. Gravity is still 9.8 meters per second squared. But our height now is 5 meters. All right, so we've got our potential energy in here. So 5 times 9.8 times 5. So now we've got 245 joules of potential energy. So we're less than our initial total energy. Where is that other portion of our total energy since we're less than 490? Well, it's going to be in our kinetic energy. So again, just like we did over here, we're going to use our mechanical energy equation to figure out how much of our mechanical energy is now in the form of kinetic, because we already know 245 joules of it is potential. So again, referring back to our total mechanical energy, because it cannot be created or destroyed, 490 joules equals our potential energy. We just found that at this point it's 245 joules, and kinetic energy is my unknown, so we will leave it as a variable. To solve, I'm going to subtract 245 joules from each side, minus 245 joules. It's going to cancel over here on the right. I have to use my calculator to figure out on the left. So 490 minus 245. Oh, that's nice. Look, it's 245. Oh. 245 joules. If you think that I was planning all of these nice, pretty numbers, I am 100% just getting very lucky this morning. So 245 joules equals my kinetic energy. Last step, I want to know how fast it's going at this point. I want you to go ahead and make a prediction. Do you think my marble would be going slower or faster here at a height of 5 meters than it was at a height of 0 meters? I'm not going to tell you yet, just make your prediction. So let's come down here and solve for velocity. So I'm looking for V. My kinetic energy is 1/2 mass times velocity squared. I'm going to bring down what I know kinetic energy is equal to at this point. So 245 joules equals 1/2. My mass is still 5 kilograms. And V is my unknown, so again, we're going to have to leave it as a variable. So again, let's combine 5 times 1/2 right here. So now we have 245 joules equals 2.5 times our velocity squared. Because these two are multiplied, to move the 2.5, we're again going to do the opposite of multiplication, which is division. I'm going to divide both sides by 2.5. So I brought down the v squared on the right because the 2.5s have canceled. Here on the left, 245 divided by 2.5 is 98. So on this side now we have 98. All right, last step. I've got to get rid of the square. So we will square root each side. So my squares canceled. So on this side I know I just have velocity. And then I'm going to take the square root of 98. And we get, oh, ruined it. Now I've got decimal. Yeah. But it's physics. Expect a lot of decimals, especially when you guys are doing your own calculations. I'm going to round, just going to round to the 10th place. So I would have 9 point, and then to round to here, 9 is going to make this round up. So I'm going to have 9.9 meters per second. So let's come back up here to the little diagram. The velocity here is 9.9 meters per second. So the trend I want you to notice is here, and I'll make a note of it. We started from rest, so our velocity at this point is 0 meters per second. As our object rolls down this hill, as it comes down, our potential energy is being converted to kinetic energy. When it reaches this lowest point with a height of 0, all of our potential energy has been converted to kinetic energy. So at our lowest point, where we have all kinetic energy, we're going to see our fastest velocity. As the object moves back up here, it's going to start gaining potential energy. So some of our kinetic is going to go back to potential. We don't go all the way back to all potential energy because we're not at the same highest point. So right here, we've got a combination of potential and kinetic energy. We still have the potential to fall farther because we have a height of 5, but our object is moving because some of that potential energy from up here is still in the form of kinetic. So that's the importance of this mechanical energy equation. All right, remember, you can re-watch this video at any time. It's going to live here on Blend. If you have any additional questions, remember, always come see me and ask. But good luck building your roller coasters today.